All right, it's about 12. I see the number still goes up as participants. So I'll just go ahead and get started. Um, Hi, everybody. My name is Jare. I am the student volunteer lead of Dashu and also the host for today. So has been a great privilege for us to have invited Yihui to join us for a super hands-on session of this time's webinar. So before I get started, as we have many registrations, we hit our historically high again, about 1,000 people registered. We say that every time, but thank you very much for your interest in joining our online webinars. So before I hand over my screen sharing right to Yihui, let me quickly introduce Dashu to whoever just joined. So we are a 501c nonprofit organization founded about 4 years ago in the United States. Joining our member is free, and we do very often host a lot of activities, either virtual, online, or in real world. So we have our monthly journal club as you joined today, and we also host several career development events, technical seminars, and definitely stay tuned. And Dashu is dedicated to provide a virtual community for all of those who are interested in data science. And we are always welcoming new members joining, and we always actively seek new volunteers. So let me just quickly stop this person's video. Okay, if you have any questions or if you want to join as a volunteer, please contact our email or follow our WeChat, LinkedIn, Twitter, all kinds of social medias we have them. And we also need your support. We would first of all want to thank whoever have donated for this session. Thank you very much. And you can make your donation through all kinds of sources on our website. And also we recorded our previous talks in the slide decks, and they're freely available on our website. Also subscribe to our YouTube channel, Dashu. We have our previous videos. Our last month's session, we have Dr. Yu from UC Berkeley, who talked about the principles of data sciences. The video is already uploaded on YouTube. If you have missed that, definitely check it out. And our next speaker in December is considering the statistical considerations in the clinical development of novel cancer drugs. So while I'm introducing, I just encourage everybody still keep yourself muted. Also, don't share your videos. If you have to do so, I will stop it. So coming back to our next speaker in December, we have Dr. Bo Huang from Pfizer, who is Director of Biostatistics and the Ecology Statistics Group Lead. He's an expert in the global clinical development of medical products, and he is going to talk about the novel cancer drugs and the clinical statistical evaluation for the current very popular immunotherapy. All right, coming down to our main cast of today, we have Yihui, who is a PhD, who is a software engineer from RStudio, joining today. He got his PhD in statistics from Iowa State. I believe many of you are very, very familiar with this legendary type of hero in R, as he has contributed significantly to the community with his great research in the interactive statistical graphics and statistical computing. And he is well known for many, many very useful, commonly practiced package nature. And also he has contributed significantly to Shiny and R Markdown. He has authored several very useful books, and those books are sold on Amazon. So you can definitely check it out. The prices are friendly. So Yihui, please give me some free books. So Yihui is a legendary type of hero behind R and RStudio. Not even to mention all kinds of honors and awards he has received. By the way, from this CV available from his website, we can sort of tell Yihui, although he has great achievements in art, but he is a very modest scientist and software engineer. He hid all of those great honors and awards amongst those awards he has achieved as a student. So definitely check out Yihui's homepage. You can find many useful information, how to code art better, how to contact him, how to be a good chef, a good father, or sportsman. So it's very interesting. Definitely check out the homepage. Okay, without further ado, I would like to hand over my screen sharing to Yihui. I see we still have many more participants joining now. So today we're gonna have Yihui talking about many very useful hands-on tips and how we can leverage that to make better use of our Markdown. All right, Yihui, I'm gonna mute myself. Feel free to unmute yourself and start sharing your screen.
Okay. It says I cannot share. I cannot start screen share while. Oh, okay. All right. Here we go. Alrighty. I guess you can see my screen now, right?
Yeah.
Okay, great. All right. Hi, everyone. This is Yihui. So today I'm going to introduce some tips of using R Markdown. So I will try my best to talk about them. I probably won't be able to finish all the 15 tips. So some of the tips will be very brief, but the good news is that I have plenty of examples along with this talk. So if you missed anything, you can go back and download the examples by yourself and play with them. So first of all, I have given many webinars, and it always feels weird to do a webinar because you have to talk to a wall in an empty room for an hour. But anyway, I'm an introvert, so that's not too bad to me. I can comfortably unite separately in my own home. So Dashu actually promoted this talk in the Chinese community using the title that I can roughly translate as the Joker Yihui, who unfortunately became a statistician, is going to introduce some awesome tips about R Markdown. So this this has put quite a bit of pressure on me because it makes me feel if I fail to tell enough jokes in this talk, the organizers would never want to see me again. So anyway, this talk is mainly about R Markdown tips instead of jokes. I guess you all know that. So the first tip I want to talk about is TinyTech. So the TinyTech is a custom TechLive package that I made about 2 years ago. And my main motivation was that all the main LaTeX distributions are just too big, like TechLive, MacTech. There are several gigabytes. The TinyTech is pretty small. It's about 150 megabytes when installed. You can install TinyTech using the R package TinyTech. So just to clarify, the lowercase TinyTech stands for the R package, and the camel case TinyTech stands for the LaTeX distribution that I made. So you can install the LaTeX distribution TinyTech with the function install TinyTech in the R package TinyTech. So one advantage is that TinyTech is very small, and the other advantage is that when you compile LaTeX documents through the R function LaTeX make LaTeX MK in the TinyTech package, several things can be done automatically. For example, the missing LaTeX packages can be automatically installed, and the LaTeX document can be compiled for the correct number of times to resolve cross-references. So you never have to remember how many times you have to run PDF LaTeX and how many times you have to run things like BibTeX or make index. So I'm going to show you the first demo. So that is the example number 1 in my example folder. So I have already, just to show you how the installation of LaTeX packages work, I have intentionally removed two LaTeX packages in my TinyTech. So then if the next time I compile this R Markdown document to PDF, you can see that TinyTech will automatically search for the missing LaTeX package using the file names like found in the LaTeX log, like hyperref.style or framed.style, and automatically just install them. So you almost never have to worry about your missing LaTeX packages again. So after these missing LaTeX packages are installed, your R Markdown document can be compiled to a beautiful PDF document. So that is how the installation of LaTeX packages work. So basically, this reminds me of this quote-unquote fun and creative guide to draw an owl. So basically, step 1, you draw 2 circles, and step 2, you just draw the rest of the damn owl. And I thought about this because sometimes it's similar when you want to create a PDF. But TinyTech has made this super easy. But basically, the first circle that you draw is to install TinyTech, and the second circle you draw is to create an R Markdown document, and then you can ignore all the intermediate steps, like whether how can I install Pendoc, how can I install a LaTeX distribution, how many times I should run PDF LaTeX or BibTeX. Do I have to contact my IT to install the missing LaTeX packages? You can ignore all these steps. You can just ignore all the intermediate steps and install TinyTech, create an RMD file, and then you get a PDF. And the second tip I'm going to introduce is how to generate a report from an R script instead of an R Markdown document. So the idea is that you don't have to create an R Markdown document. You can write a pure R script. And there are just some special syntax, like you write your narratives or text after Rockstring comment. A Rockstring comment starts with a pound sign followed by a single quote. So that is where you write the narratives. Remember, these narratives are totally optional. So you don't have to write documentation or text or narratives. You can just write pure R script. But in case you do want to write narratives, you write them after this special comment. So then you can write some R code, and you can write more narratives, and you can draw plots. And if you want to tweak the appearance of your chunk output, you can add some chunk options using the syntax of a pound sign followed by plus. So the chunk options are also optional. It depends on whether you want to tune the output of your report. So behind the scenes, the R script is actually compiled to an R Markdown document through the function spin in the nature package. And then R Markdown will, the render function in R Markdown will compile this report to the final output format, like PDF or HTML. So now I'm going to show you the second example. 02 spin. So this is just an R script. If you are using RStudio, there is actually a little button on the toolbar that says compile report. So just this notebook button, you can click this script directly to a report. So you can see you have graphics output. You can have some like the inline output, like the value of pi is 3.14. All these are written in the R script. So if you don't use RStudio, you can just call the function Markdown render, then just input the file name of the R script, like 02-spin.r. You can render this R script directly to a report. So that is something that's not widely known, but I think it's a pretty cool feature. So actually, someone discovered this spin function in 2015, and he basically shouted out loud that spin is Knitter's best hidden gem. And this reminded me of a painting. I think this is very famous, the Scream. So that guy actually screamed when he discovered that an R script can play the same role as an R Markdown document. So originally you thought, oh, I can only use R Markdown to generate a report, but later you realize that, oh, I can also use an R script to generate a report directly. So it doesn't matter if it's a human face or a dog face. And the third tip that I want to share is how to convert an R Markdown document to an R script. This is basically the opposite of the second tip. The second tip is about how to compile R script to R Markdown, and the third one is how to compile R Markdown to R. So, and the function to call is the Perl function in Knitter. So I have the example number 3, 03-perl.rmd. So this is an R Markdown document. If you want to extract all the R code in the R Markdown document, you can actually just call the function Perl in Knitter 03. So now an R script 03-perl.r is generated here. You can see the Perl function has extracted all the R code from the R Markdown document. See, I have 2 code chunks here: summary, cars, and plot pressure. And actually I have a third chunk here, but I set the chunk option Perl equals false. That is why this code chunk didn't appear in the R script. There are a few, there is actually an argument of the Perl function named documentation. This argument controls how much documentation you want to see in the R script. For example, if you specify documentation equals 0, basically it will extract the pure R code. So previously you saw I think you saw the chunk options and the chunk labels, but now it's just pure R code. And you can also set this argument to 1 or 2. 1 is the default value. Let's try 2. If you say documentation equals 2, then in the R script, you get the full documentation, the full narratives. All the text is also exported to your R script, but all the text is actually put in the Rockstream comments. So documentation equals 2 means the full documentation. So that's the third tip. So hopefully now you have realized that all R Markdown documents are actually just R scripts wearing text masks, just like that all the ducks are actually wearing dog masks. And the fourth tip is citations. So there are several ways of adding citations to an R Markdown document. I'm just going to introduce one, which is through a BibTeX database. And there's actually a function named writeBib in the knitr package that can help you create a BibTeX database that contains R package citation entries. So as a simple example, you can cite the base R package using the BibTeX entry like this. So if you, the first argument of writeBib is a vector of package names. So here I'm just using one package base. So writeBib will output a BibTeX entry like this. So if you're familiar with BibTeX, you know that first you specify the type of the citation, like menu, article, book, or other things like conference proceedings. And then after the type of citation, you have a citation key. So that key will can be used for citing this entry in your document. So once you've got the citation key, like RBase, then you can use the add sign to cite that entry, like add RBase, or you can use square brackets so that this citation is put inside a parenthesis, or you can cite multiple entries using multiple keys separated by semicolons. So now I'm going to show you the fourth example. Number 4, citations. So what I did here is that I called the writeBib function in knitr, and I passed a vector of package names. So, oops. So this is just a vector of package names. I pass these package names to writeBib, and I want to write all the BibTeX entries inside a file named packages.bib. So this is the first thing you do when you want to cite R package. And then the second thing you have to do is to specify a YAML field named bibliography. So bibliography, then you pass the file name to the bibliography field. So then, as I said, you can use add RBase or add rknitr to actually cite these packages. When you compile this document to either HTML or PDF or Word, these citations will be automatically added. So that is about citations. So one thing that I want to mention is that oftentimes you often cite things like papers, but it's still not very common for people to cite software packages. And I really hope that people can acknowledge their helpers. Like if an R package or some R packages have been useful to you in your paper, I really hope that you can cite them. And the writeBib function in knitr can really help you with that task. The fifth tip is about cross-referencing figures and tables and citations. Sections. To cross-reference these things, one way is to use the bookdown package, even if you are not writing a book. So, so there are several output formats in the bookdown package that you can use, like HTML document 2, PDF document 2, Word document 2. So the key is that you use the syntax \@ref in parentheses, then put your the key of the reference in the parentheses. So I'm going to show you the example number 5. So I have 3 outputs in this document, and I have a plot with a chunk label cool and a table with a chunk label nice. So after I create this plot and table, you can cross-reference them using the keys. Like if it's a plot, if it's a plot, then you add a prefix fig in colon followed by the chunk label, like fig colon cool. Or if it's a table, you use the prefix tab colon nice. And then if you want to cross-reference a section, you just use the section ID that I specified here after the pound sign. So I can knit this to HTML. You see here's figure 1.1, table 1.1, and then in the second section, you can say see figure 1.1, table 1.1, and section 1. So all these cross-reference numbers are automatically generated by Markdown. So that is what you do when you want to cross-reference things. So with the automatic cross-references, you will never mistake figure 3 for figure 4 again. So because all these cross-references are dynamically generated from their IDs instead of like hard coding the numbers. And the sixth tip is about the inline output of a character vector. So oftentimes you may want to output a phrase like apples and oranges, or if you have several items, you want to separate them by commas, and before the last item, you want to add a word and, like A, comma, B, C, D, and E. So there's a function combine words in the knitr package that can help you. So for example, if you pass the first 5 letters to the combine words function, you get A, B, C, D, and E. And then you can pass an arbitrary character vector like hook, line, sinker. Then the output will be hook, comma, line, comma, and sinker. So now let me show you how to use this function in inline expression in R Markdown. So for those who are very familiar with R Markdown, you probably know that you can, besides the R code chunks like this, you can also write R code inline. The syntax is a backtick followed by little r and then a space. And then you write your R code, and at the end, you add another backtick. So that is how you can embed an R expression inline. So in this inline expression, you can call the function combine words. So in this example, I just want to output the variable names of the iris dataset. So the combine words function has several arguments. So you can go back and check out the documentation. So here I just want to quickly show you some of the examples. So like for the first paragraph, it's just the plain variable names. The second paragraph, I added the argument before equals a double quote. And then in the output, you can see all the variable names are quoted with double quotes. And similarly, you can add a backtick to the variable names or add curly braces around the variable names. So that is how you can output a character vector with the function combine words. Yeah, I guess everybody knows the importance of the Oxford comma. So like with the Oxford comma, it's clear that what you mean when you say we invited the Rhino, Washington, and Lincoln. You know, there are 3 objects, the Rhino, Washington, and Lincoln. Without the Oxford comma, Washington and Lincoln will become the rhinos. Right? We invited the rhinos, Washington and Lincoln. And Washington is a rhino and Lincoln is a rhino. If you omit the Oxford comma. The 7th tip I want to share is it is a very simple task, but not many people know how to do that. The question is how to add a line break in the output. If you use raw LaTeX, you know that two backslashes means a line break. In HTML, you know the tag BR means a line break. But in Markdown, what do you use? You can't simply break a line in the Markdown source because that will not work. The line break will be ignored by default. So the answer is that you need to add 2 trailing spaces if you want to break a line. So to make it clear, let me show you the 7th example. So for example, sometimes if you want to quote a poem, in that case, you may want to break all these lines without introducing new paragraphs. Like when you introduce a new paragraph, you just add an empty line. But within a paragraph, how do you break that line? The answer is add two spaces after that line. And when the text is very long, it might be tedious if you add 2 spaces after every line. To make this easier, I actually have an RStudio add-in in the Markdown package named quote poem. So if you select the text and click this quote poem, add in, then every line, you can see on every line there are 2 spaces added. So now if you need this document, you can see all the lines are properly broken. So you can see the actual poem by comparison. So that add-in actually works on any characters, including, of course, Chinese characters. But for this, for the Chinese version of this poem, I didn't add the 2 trailing braces. Then you can see all lines in the Markdown source are actually ignored. So they just became 1 paragraph. So similarly, I can select the text here and click the add-in quote poem. And then if I need this document again, you can see the lines are broken again. So that is how you add line breaks to your document. So as I said, this is a very simple task, but many people didn't know the 2 trailing spaces. So if next time if you are driven crazy by this kind of simple tasks, you can go to the Pendoc menu to read menus, or the full Markdown syntax is documented in the Pendoc menu. You can go to pendoc.org to read the full menu. The 8th tip I want to introduce is how to put all your code in the appendix instead of the body of your report. And the answer is to use the chunk option ref.label. So I have written a blog post about this topic. So you can go to that blog post to read all the details, but here I'm just going to show you a quick example. That is the 8th example here. So in this R Markdown document, I have several code chunks. The first code chunk is 1 + 2. The second code chunk is 3 - 4. And then you have actually all these code chunks will be hidden in the body of the output document, because I have set a chunk option echo equals false globally. So I'm using nature : ops _ chunk $set echo equals false. That means I want to set the chunk option echo equals false globally. So the source code of these chunks will not be shown in the output. But in the appendix section, I have a code chunk where I set the chunk option equals true because I want to show some R code here. And then I have the chunk option eval equals false because I don't want to run this code chunk again because all the code chunks have been executed previously. And here in this code chunk, I just want to show the previous R code. So the last chunk option is the most important one, ref.label. So ref.label takes a character vector of chunk labels. So if you pass some chunk labels to this ref.label option, knitr will extract all the chunks according to their labels into this chunk. So like knitr : all labels, this function actually gives you all the chunk labels in this document. So if I pass the result to the ref.label option, then all previous code chunks will be extracted to this code chunk. So let's see how it works in the output. So as I said, I have set echo equals false globally. So for the first two code chunks, you don't see their source code. You only see the output. But in the appendix, I have the ref.label option. So all the previous code chunks have been extracted and placed in this code chunk. You can see the code chunk, the first setup code chunk, the second code chunk 1 + 2 here, and third code chunk 3 - 4 here. So that is how you can put all your R code in the appendix instead of the body of your document. And of course, you can select some code chunks to display in the appendix. So instead of calling the function all labels, you can manually specify some code chunks like here I have a character vector of length 2. The first element is some code. The second element is more code. Some code is the label of the first code chunk here, and more code is the label of the second code chunk here. So then in this code chunk, I only show two code chunks, two previous code chunks. So you can display code chunks selectively in your appendix. So just remember the chunk option ref.label. So with ref.label, you can move your code freely in an R Markdown document without cut and paste. So you don't have to repeat your R code across several code chunks. You can just use ref.label to borrow source code from other code chunks using their labels. And the ninth example I want to show is how to create an animation. Actually, if you go back and check out the slides, I have a link on the slide title here. That is actually a blog post I wrote earlier last year. So you can see all the details there. So here I'm just going to, I will just be brief. So if you want to create a GIF animation from all your R plots in a code chunk, you can install the GIFSKI package from Tran and then use the chunk option animation.hook equals GIFSKI. So this is the source code of the code chunk. So you specify the chunk option animation.hook equals GIFSKI, and then inside our code chunk, you can just create as many R plots as you want. And then eventually knitr will combine all the plots into an animation. For example, here is an animation of the Pac-Man using two pie charts. So I'm going to skip the R Markdown example for this tip, but because this is just simple enough. So I hope you can enjoy your custom animations in your R Markdown document. And then the 10th tip is Actually, someone just asked that is there a way to avoid recompiling a heavy chunk? That's exactly what I'm going to talk about here. The 10th tip is to cache a time-consuming code chunk. So basically, the answer is you can turn on the cache. You can turn on the cache using the chunk option cache equals true if that code chunk is very time-consuming. Once a code chunk is cached, you only need to compile that code chunk once. Because the next time, if you don't change anything in the code of that chunk, then the results will be automatically loaded from cache instead of being re-evaluated. So hopefully that will save you quite a bit of time. But caching is actually a very complicated topic. So I would like to warn you that there's no free lunch. So using cache equals true, sometimes it can help a lot. Sometimes it might bite you because simple tricks often have costs too. So I have written a blog post on this topic too. So you can go back and click that link where I wrote extensive on the topic of cache invalidation in iter. So it's just like if you want to quickly lose 10 kilograms of your weight, there's a simple trick. You can use your toes to cover the number 6 to make 6 to 5. So you can lose 10 kilograms. But often, as I said, simple tricks often have costs. Using cache equals true, it may help. It may or may not help. It depends on how complicated your R code structure is. Like sometimes your code chunks may have may depend on each other. If you cache the second code chunk, how can and change the first code chunk, how can the second code chunk know that something has changed? So the cache has to be invalidated. And the 11th tip is how to add logos to your R plots, or actually more generally, how you can post-process your plots. There's a chunk option named fig.process, which can take a function to post-process your R plots generated from your R code chunk. So I'm going to use an R package named magic for demonstration, because this is a very cool package. Example number 11. Oh, actually, if you want to ask questions, I will be able to answer them at the end of this talk, because it's a little difficult for me to give the talk while looking at the chat window. But hopefully someone else, there are other experts in the attendees that they can probably help you. I will take a look at the questions at the end of this talk. So for the 11th example, I'm using the magic package to post-process R plots. So basically what I'm going to do is that I will write a function, magic underscore proc. So this function will take the path of an R plot and post-process that plot. So hopefully you can see some image effects in a minute. So basically the fig.process function has two arguments. The first argument, x, is the path of that plot file. The second argument, options, is the chunk options of that code chunk. So basically in this function, I'm taking a plot file, and then I will apply a function from the magic package, apply that function to that plot, and then write the plot back to the to the path of that plot file. So here so this code chunk shows the original R plot, and in this code chunk, I'm using the figure.process function. What I'm going to do is that I will blur the plot there. So remember, I just talked about the ref.label function. So this is a great way of borrowing R code from another code chunk without copying or pasting our code. Ref.label equals original. So basically means that the R code for this code chunk will be the same as the code chunk up here. So I'm using magic proc function to post-process the R plot there, and I will pass some additional arguments to the magic function, including radius equals 10, sigma equals 5. And then in the second example, I will show the charcoal effect. So I will call the magic function magic : image charcoal to process the plot. And similarly, in the third example, I will negate an R plot. So let me compile this document so that you can see what this post-processing functions do. So as I said, this is the original plot. It is my version of the Starry Night, which is essentially a density plot overlaid by a sunflower plot. And then the blurred version is from this code chunk. I'm using the magic proc function to post-process that original plot so that this plot is blurred. And in this code chunk, I'm using the charcoal image charcoal function to bring the charcoal effect to the R plot. And for this plot, I'm using the image negate function to negate the colors of that plot. I think this as I said, the magic package is very, very cool. I really love it. And then the last example in this R Markdown document is how to add a logo to your R plot automatically. So here I wrote a function named add logo. Basically, I'm still using magic functions. Just read that plot and also read the R logo. And then eventually I'm using image composite to add logo to that image and write the new image back to the R plot file. So now I'm using the chunk option figure.process, and it takes the function add logo. So, and I'm still using that sunflower plot. So for this code chunk, it will add the R logo to the upper left corner of your R plot, but you can also customize the location of that logo using additional chunk options like magic.gravity. Magic.gravity is used in the add logo function here. So that gravity is passed to the composite function in magic. So gravity basically means where you want to add that logo. So if I specify northeast as the gravity of that logo, then the logo will appear in the upper right corner of your R plot. So that is how the fig.process function works. Hopefully now you can feel that the figure.process option has pretty strong force, and I hope you can be creative and you can use your imagination to decorate your R plots. And the 12th example is how to add real LaTeX math expressions to R plots. If you're familiar with base R graphics, you probably know plot math. If you don't, you can check out the help page, plot math. But these tricks in base R actually do not produce real LaTeX math expressions. if you want to write real LaTeX math expressions in rplots, there is an R package for that, which is TIX device. The question is how to use TIX device in R Markdown. The short answer is that you use chunk option def equals TIX. But there are several problems because TIX device only produces PDF output, LaTeX and PDF output. And sometimes you may want to use math expressions in your R plots in HTML output. And here I have an example in which I can convert PDF images to PNG images, so that because only PNG images work in HTML, PDF images do not. So that is how that is just one extra thing that you have to know when your output format is HTML. So here I'm using the fig.process option, and it takes the PDF to PNG function to post-process PDF to PNG. But that is not the key. The key is def equals TIX. So here in this plot, you can see I'm using real LaTeX expressions. I can put math expressions in $signs. So let's first compile this document to PDF, which does not require post-processing. So you can see this is a real LaTeX expression. You can see the density of the normal distribution. And you can also compile this to HTML. Because this is TIX, the TIX device package is often very time consuming to generate rplots. So that is why I turned on the cache option. So you can see here's an HTML page, and the LaTeX math expression also works there. Right. So that is the chunk option def equals TIX. So with that, to create beautiful math expressions in your rplots, you definitely need some advanced skills. And it's not a trivial task, but you can certainly do it once you know which package to use and which chunk option to use. And the 13th tip is how to use other languages in R Markdown. Although it is called R Markdown, you can actually use other languages besides R. You can embed Python code chunks in your R Markdown document. You can call Julia, you can write SQL, you can write C++ code, you can write shell scripts, JavaScript, CSS, and many other languages. To know all the languages supported in the knitr package, you can call the function knit engines$get. There are more than 40 languages supported in knitr. So when you want to play with other languages, you just change that little r in chunk header into the language name. For example, if you want to write a Python code chunk, you just use Python instead of R. Now I'm going to show you the 13th example. Here. The Python is on an R package named reticulate. So you have to install that reticulate package first, and then you can create Python chunks like assign a value 42 to a variable x. And then in the second Python chunk, you can print the output of x times 2. And from an R code chunk, you can actually access the Python variable using the object pi. $x means the variable x in the Python section. You can also create Python objects in an R code chunk, like I want to assign a vector from 1 to 10 to the variable y in the Python session. And then in the Python session, you can print the value of y. Similarly, you can write shell scripts using sh as the language name here. I'm going to compile this document so that you can see the output. This is a Python code chunk, x equals u, and from an R code chunk, you can access the value x from the object pi. You can create a a Python object from R using $y equals 1 to 10, and then you can print the variable y in the Python session. And you can play with shell scripts like echo the environment variable home, or list the files with the extension HTML. That is a quick example of other languages in our Markdown. So actually, so all the code chunks of all different languages worked perfectly in the previous example. Here you see Python, you see Julia, you see SQL, you see R. So all the languages will just work in an R Markdown document. The 14th tip is about child documents. So when your document is very long, you can split the long document into shorter ones and include the shorter documents as child documents of the parent document. And the key is to use child option in the chunk header, where you specify the path to that child document. You can use one child or multiple children. Just if you want to use multiple child documents, you just pass a vector of file names. Yeah, so you can have as many happy child documents as you want in a parent document. Everything will just follow. The last tip I want to demonstrate is bookdown and blogdown projects. So if you are interested in writing a book, you can create a new project in RStudio, new directory, new project using bookdown, and give it a name like test book, create a project. So for a bookdown project, you have more chapters. Each chapter is inside one RMD file. And once you've got all these chapters, you can compile these multiple chapters into a book. Like you can have the HTML version of the book. You can also build a PDF or an ebook. So the key is that you have to go to the build panel in RStudio and click the button build book over there. So that is a bookdown example. Next, I'm going to show you a blogdown example to create a website. So similarly, you can create that project in RStudio and give it a directory name, and you can specify a theme. Use xmin here, create project. And with a project, you can have as many pages or posts as you want. And once you've got all these pages and posts ready, what you are going to click is the add-in serve site. So serve site will compile your website and show it in your RStudio viewer. So this is just your website. And the nice thing about blogdown is that you can once you click the serve site add-in, you can just edit your R Markdown source or Markdown source file in the editor. Like this is my full site. You can just save the source file, and the website will be automatically recompiled. And you can see your viewer will be refreshed, so you can live preview your website. And there are many, if you want to know the full details about bookdown and blogdown, I have 2 books for them. Sometimes you may feel scary that, oh, I'm going to write a book. That sounds complicated. Create a website. That also sounds complicated. It's not that scary. Once you just create the new projects in RStudio, you get some decent examples. You can edit the existing R Markdown documents or add some new R Markdown documents. It's totally really not that scary. So the last example I want to show is some fun with R Markdown. So once R Markdown is combined with Shiny and especially JavaScript, it can be even more awesome. So this is an Markdown example that I made a couple of months ago. Once it's combined with Shiny, you can actually make your Markdown output dynamic and interactive. So you can have some widgets in your Markdown document. You can interact with them. And below here is an example of using your camera to control a simulation of, so here's a simulation of the value of pi. So hopefully it's based on face detection. So when I'm looking at this example, the simulation will just continue. When I turn my face away, it will stop. So you can see this is, sometimes I just build funny examples like this. So yeah, the simulation is just like, I'm the boss of this simulation. When I'm looking at this simulation, it will work. When I don't look at it, it will just stop. So this is, yeah, just a fun example. The example by yourself. So that is all I have for you today. So as I said, the slides and all the examples are public, available online. You can go back and check out slides and download the examples and play with them. Thank you very much. So now I can take a look at the examples if you have any.
All right, thank you Yuhui, very much. We have lots of thank yous in the chat room right now. I know we went over a little bit more time, but if you love to stay a few minutes more to answer some of the questions from the audience, that would be really appreciated. So I guess everybody's like, keep saying thank you. So whoever want to ask questions, you can leave your question in the chat box, starting with the big capitalized question. We had several questions posted earlier. If you just scroll up, Yuhui, I don't know what time and permits, and you can try to answer selectively some of those questions too.
Okay, I will scroll back.
Yeah. By the way, thank you for making this awesome slide deck. I just can't imagine how much time you have spent on finding all of those memes. It's awesome.
You're welcome. Oh, sorry, my reading speed is very slow. Okay, I've seen someone's Amy Kim said my add-ins does not have code poem option. Do I have to install something? Yes. Sorry, I forgot to mention this. If you want to use the quote poem add-in, you have to install the Markdown package. So basically, from the package, install Markdown, and then you will see the quote poem add-in. And then Hossein asked how to avoid long lines of code not to go out of page margin when needing to PDF. That is a very tricky question. It's hard to answer that verbally here, but it'll be a good question for posting to Stack Overflow or our Studio community. If you don't get any answers there, I will be happy to take a look at the question.
If we have several more questions being posted of those who haven't left, because
Okay.
Yeah.
Is there a way to use colors in Markdown document? Yes, actually, this year I have been writing a book, and I have exactly one recipe for using colors in Markdown document. It's a little bit tricky because it depends on your output format. If the output format is just HTML, you can use HTML tags. Like you can use CSS to color your text. If it's LaTeX, then you have to use some LaTeX commands. But if you want both output formats, HTML and PDF, you have to use some other tricks. Again, this question will be perfect for Stack Overflow or RStudio community. Then someone asked, how do I make blog-down posts reproduce? After a few years of using it, older posts would have been made using an older versions of RN packages. Yeah, in general, reproducibility is super hard. I mean, there are several solutions. I guess the one that I could think of for now is probably Docker. If you want to strictly reproduce everything, Docker is probably the tool. I mean, because you will be able to recreate the whole operating system. So in that environment, you should be able to reproduce the results from your older posts. In R Markdown, in producing PDF, how can we enforce the position of figures? Sometimes plots are not matched with body text. I guess you're asking about, you're asking about the PDF output. Yeah, usually it's very surprising that figures float away from your text, and that is the default behavior of LaTeX. You can certainly force the position of figures. There is a chunk option named figure, fig.pos, figure.position. If you specify that to capital H, it should force the position of the figure, but well, again, this kind of question it's hard to answer verbally here. Yeah, if you can ask it someone elsewhere, I will be happy to take a look at that. But the key is figure.position. Then is there a way to incorporate macros header files to R Markdown with HTML output as for LaTeX output? Yes, if you want to add anything to the LaTeX preamble or the HTML head tag, you can use there's a sub option named includes under the output format, like under HTML underscore document or PDF underscore document, you can use a sub option named includes. You can read the pages of the formats to understand how to use the includes option, includes sub option.
All right, I guess we're running a little bit over time here, Yihui. I encourage the audience to ask your questions. So Yihui is online on GitHub every day, and also you can check out his homepage and leave your questions in there. And he has a particular guideline, imagining how busy Yihui can be every day answering questions. I can imagine that based on the enthusiasm right now in the audience. So you can post your questions on Yihui's homepage and check his GitHub or try Stack Overflow. Last but not least, I want to thank Yihui again for joining today's Dashu's online virtual webinar. It's a successful event. Thank you very much for sharing all of those super useful tips of using R Markdown. We couldn't wait to hear more about you in the future. So please feel free to come back in another day, anytime you see the enthusiasm from the community. I want to thank you again. So thank you very much. Thank you for the audience for joining. Thank you.
Thank you.
Yes, the slides will be available in here, and we will upload this session in the YouTube channel. So definitely stay tuned, everybody. Thank you.
All right.